All right, so we're good to go. So welcome back. So let's talk about PA1. So hopefully everybody got PA0 done, and there were two people who were having some technical difficulties. So I sent each of you emails through Canvas. So so please, everybody, make sure you check your Canvas emails. And if you got an email from me about the first programming assignment, write back to me and let's figure out the technical issues. So let's move on to PA1. So this is available on Canvas, but let's run through it. And let me close my window again because it's kind of noisy outside. Which is too bad because it's actually kind of nice out. All right, so programming assignment 1, you're going to create a class on your own, similar to how we made the rectangle class. Okay, same basic idea. It's going to be one class. It's going to be a class called even, so it'll be in a file called even.java, and you're going to create some constructors, some methods, accessor, and a toString method. Okay, so it'll be very similar to what we did yesterday. By the way, I opened up an area on Canvas that points to where you can download code that we write along the way. So I'll push code up to the Linux server, and you can find it through the Canvas link. So start this early, okay? It's due a week from today. But object-oriented programming is a different mindset the first time you encounter it. So don't wait until the last minute, because you've got to get your brain to kind of a different programming, right? It's got to sort of rewire itself to think in terms of objects. And that takes a few days of kind of struggling with it. So really, if you start it the day before, maybe you'll get something turned in and you'll get some points. But the real goal of assignment 1 is to get you thinking about objects, okay? Get you thinking about not writing C in Java, but about writing object-oriented code in Java. So this is an important exercise in that sense. Do not use any sort of IDE, though. I want you to work strictly from the command line until further notice. Don't use Eclipse, IntelliJ, anything else like that, okay? You need to learn the basic syntax. You need to write public static void main parentheses string bracket bracket args close paren curly bracket over and over and over again so that you can recite it in your sleep, so that when you come to an exam or an interview question or something like that, you don't have to stop and think about it. It becomes second nature. Okay. Eventually, we'll start working with an IDE to do some graphic stuff. But for now, just stick to the command line on the Linux server. Java C to compile, Java to execute. Okay. It will definitely pay off doing that, even though it's a little more painful initially. Okay, so for this assignment, you're basically making a class that looks like the integer class, except it only works with even numbers. Okay, so you're going to make a class called even that basically represents an even integer. And you can add, subtract, multiply, and divide, and you can print these out, and so on. Okay, so details. Class must be named even, uppercase E. You are only going to be writing the class. You're only going to be turning in the class even.java. Okay, you're going to write your own main programs to test your class, hopefully, but the only thing you're submitting is the class itself, even.java. So make sure it's named, exactly this, because that's what my test program is going to look for when we link things together. All right, so you're going to have a single constructor. You would build an object of type even with a statement like this: even x is the name of the object, equals new, and then you say even the name of the class, parentheses, and you give the value that you want to assign the number. So this makes x the even number 2. Okay. If you try to construct with an odd number, add 1 to it. So if you say even 3, you should construct the number 4. If you say even -5, you should construct the number -4. Okay, add 1 to the argument if it's odd to get an even number. Your class is very simple internally. It basically has a single integer which stores the value of this object, right? This even number. You can call this whatever you want. you could call it value or number value or whatever, but basically when you make your constructor, if your argument to the constructor is even, just save it in this field, what we call a class variable, right? Like the height and the width in the rectangle. And if the argument to the constructor is odd, add 1 to it and save that in the class variable, whatever you choose to call it. And then you have a set of methods for add, subtract, multiply, and divide. Okay, add, each of these takes a single argument, which should be an even. Okay, so if x is an even and y is an even, and you say x dot add y, that should return an even, which is equal to the value of x plus y. Okay, so inside this method, you need to get the value of y, you need to get the value of x, you need to add them together, and then you need to construct a new even and return that. Okay, so let's spec that out. So so this is going to be public. Even is the type of return. Add takes a single argument. Even argument. Okay, somewhere in our class we're going to have a value where we're storing the actual value of this even number, and I'm just going to suppose that we have this, private integer. I'm just going to call it value. So private int value, this is, value of this even number. All right, so how do we add arg to, this value? A first order approach might be something like, integer sum. And we could say sum equals value plus argument value. Okay, and if you don't make this value field private, this will work. Okay, that's good for a first order test. But eventually we want this value to be private so that somebody else cannot come in and explicitly set this to an odd number, right? Which would break our whole universe. So we can't really do that, but we can do value plus, and if you look at this fifth method, there's a thing called toInt, a method. You can pass an even, take an even, it has a method called toInt that returns the value of the even number as just a plain old-fashioned int. So if I want this value of argument, I could say argument dot toInt. Okay, this is the accessor that we were using yesterday when we wanted to be able to read the height or the width of a rectangle even though those fields were private. So you just make a method that returns, value in this case. Okay, so now sum is equal to value plus the value of the argument, and then we could say even result, and we could say result equals new even, and pass it this integer, which is the value that we want to give this new even, this result, and then return result. Okay, so there's a way you could do your add function. Okay, now you can do this in one line. You can put everything together. You can return parentheses new even parentheses value plus arg dot toInt paren close paren, right? You can string it all together, but you can break it out like this if you want to make sure you understand what the different pieces are doing. But if you do it like this and you've got time left over, right, maybe go ahead and try to make a version where it's one line, because it's really fun to make one-liners sometimes and put these things together and let it all just kind of happen magically. But that's an idea of what you're going to do for each of these four methods. Okay, add, subtract, multiply, divide. Divide is slightly different because when you divide one number by another, right, integers, they get truncated. You might end up with an odd answer. So if the answer is odd, add 1 to it. Guess what though? If my result, if my sum happens to be odd, when I construct a new result, it's going to make it even, right? It's going to do the right thing when I do this constructor. So I don't even need an extra if statement in here to say if the sum is odd, add 1 to it, because I've got that in my constructor. Okay, so play around with this. The goal is not so much to get this done. Okay, the goal is to spend time getting familiar with Java, and this is a mechanism for doing that. Okay, this is a vehicle for exploring it. So take your time, right? Let your brain wander and explore and see what you discover. Okay, it'll pay off a lot in future assignments. Okay, the fifth method is toInt, which simply returns whatever value the integer is. So it should always return an even number, and it just returns an int. Okay, these four return evens. This function returns an int. And then the last method is the toString method. Okay, so toString we looked at yesterday with rectangles. It should be a method. It's got to be public. It's got to return an argument of type string, and it takes no incoming arguments. And it should return a human readable representation of the string. Okay, we'll come back to testing in a minute. I didn't tell you about toString. I will modify this and make it explicit. But what your toString method should do is print out your number in English, right, using a word for each digit. So if you have an even number, which is so if we say even x equals new even 12, and we print out the value of x as a string, it should print 1 space 2. Okay, so toString returns a string containing words that correspond to each digit. And if it's a negative number, it should start off with the word negative, and then 1, and then 2. And that's blatantly missing from the assignment, so I will fix that up right after class and repost PA1. But you can probably get the idea from the example code here, right? A was negative 10, B was 15, C was the sum, which should be 6, because B will actually round up to 16, and D is 16 divided by negative 10, which will be minus 1, which will round up to 0. And so if we print these out, right, A is equal to negative 1, 0, that's negative 10. B is 1, 6, that's 16. C is 6, that's just 6. D is 0, that's 0. All right, so how do you use this class? Here's some sample code, right? Even says I want A, B, C, and D to be even numbers. To actually give them values and actually make them objects that occupy memory, we have to use the new keyword. So we can say A equals new even, parentheses, give it the value. Now A is the even number 10. Okay, to take A and add B to it, we can take A, which is an even. We can use the add method and give it an argument of B. This will take A, add B to it. That will return an even, and now C, which we declared to be an even, will be given that value. So C will be equal to 6, and so on. Okay, toString never prints anything. Don't put any print statements anywhere in your code. ToString simply returns a string. Take a look at the ToString method in the rectangle class we made yesterday. It doesn't actually print. It just returns a string. So if I have an even number, I could do something like string s equals x, right? And that would take this even number, call its toString method, and then set s equal to the string negative space 1 space 2. Okay, so toString, we usually are using it in a print statement, but toString itself doesn't actually print. Okay, it's just returning a string. And then here's another test I did. I just made a loop. I set C and D equal to 2, and then I just looped 11 times and multiplied C by 2 and printed it out. So this gives me powers of 2 written out in a kind of awkward English. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 1/6, 2 to the 11th is 2048. That's 2048, and so on. All right, so any questions on what we've gone over so far about PA1? All right. So submission is just like PA0. Submit through GET to a repository called CSE 223 PA1. Okay. Same drill as before. So make sure that you submit the Java file, and make sure you add me as a reporter. Okay. You can do this today. You can make an empty directory. You can put an empty even.java in there. You can initialize Git. You can add. You can commit. You can git remote add origin. You can git push. You can go over to GitLab and add me as a reporter. And you are done worrying about Git, right? For the next 7 days, all you have to do is when you make changes, git add, git commit, git push. Okay? And it keeps the repository up to date, and then next Tuesday morning when I download, I'm guaranteed to see whatever your latest push was. Okay, so grading. So I'm giving you a rubric here for exactly how I'm going to grade this. Okay, if the class is defined properly, if I can compile your .java file to get a .class file, and if the constructor is there, you get 25 points. Okay. If your 5 methods, add, sub, mul, div, and toInt, are all defined properly, you get another 25 points. If they additionally work perfectly, you get an extra 15 points. Okay? They all have to work to get the 15 points. If you can make one work, you can make them all work. Just double check your code, okay? ToString itself is worth 15 points, and then 20 points for coding style. Okay? Coding style is going to be a big thing in this course. So we've had a few courses already to talk about this and develop it. So now I'm going to start insisting on good coding style. So what do I mean by coding style? Consistent indenting, placement of braces, and so on. Use a style that you like, but make sure that when you have an if statement, when you have a for loop, when you have a definition of a method or a definition of a class, you're indenting in response to it. And your indenting should be consistent. Okay? Double check, look at it, make sure that it makes sense. Make sure that all your code is commented, and pretty much every line of code should have a comment on it. Okay? If you say I equals I plus 1, don't say increment I. Tell me why you're incrementing I. Why are you adding 1 to it and storing it back in I? Right? What's the purpose of that? It's doing something in your code. Are you counting something? Are you waiting for some number of events to happen? Right? So pretty much every line of code should have a comment. Okay. Every method you write should have a block of comments in the beginning. For example, when you write your divide method, okay, don't just make a comment saying divide method. That doesn't tell anybody what this is, why it's there, how to use it, and so on. Here's an example of an excellent comment block. Divide method, accept an even integer and divide the current object's value by the argument's value. That's the minimum that you want to say, right? Because now somebody knows what this method is for. Accept an even argument and divide the current object's value by the argument's value. Okay. Additionally, if the result is odd, add 1. That's pretty useful to know, right? Because dividing can sometimes result in an odd number. Return a newly constructed even object with the resulting value. Because, sometimes these methods modify arguments, and sometimes they return something. No special handling for division by 0 may throw an exception. Well, that's kind of nice to know. Maybe you want a divide method that checks for a division by 0 and does something. Your divide method should not do that. If someone tries to divide by 0 and it throws an exception, it throws an exception. But mention that in your documentation for that function, so that if somebody is looking to use your package and they think they might divide by 0, they say, oh, I have to deal with the possibility of division by 0 because this person's even class doesn't handle that. Okay, so I want a comment block in front of each method. And then for the entire class, a comment block at the beginning, which describes the class. Okay, everything about the class that you're writing. This is a class of even integers. It lets you add, subtract, multiply, divide. Odd results get added, get incremented to give you an even number, etc. The two-string method, you know, prints things out in a weird way. All of that stuff, okay? And then, of course, your name, the date, the course number, and so on and so forth. Okay? Really, really, really think about the style points. It's 1/5 of your grade. Okay? Really think about it. And if you want, send me your code. Don't do it the day before, but up through the weekend, if you want, you can push your code to Git and say, hey, can you take a look at this? Tell me if the style is good. I'll be happy to download it and give you some feedback and say, you know, change this or keep that, or this looks perfect or whatever. Okay? So everybody should be able to get 20 points on this, and I guarantee you this is going to help you so much beyond Clark, right? When you're writing code for other classes at a university and you're turning it in, if your code is clean, if it's well formatted, if it's well commented, it's going to help you, okay? Because a lot of teachers, if your code doesn't work, they might take a quick glance at it, and if they just kind of see code, they probably won't dig into it. If you go and you try to talk to them about it and it's well organized and cleanly documented and such, you got a better chance of convincing someone to give you some points. Alright, I got rid of the Nick Macias 3 from GitLab, so the only one that you should find now is Nick Macias, but you know, make sure that you're adding Nick Macias as a reporter to your project. Try not to make additional subdirectories. Do not include the even.class, your main file, everything like that. I'd like you to turn in a repository which has one file in the top level called even.java. Okay? If you want to put a README in there, you can put a README in, because that's kind of a Git thing. Okay? But other than that, just even.java. So questions on that? All right. So let's talk a little about classes, and then let's play a little more with evens. Here's the main test code that I had in the assignment. And it's a class called main. It's in a file called main.java. Okay, so we know public static void main is our main program. It's like, you know, integer main, argc, argv. This is the method that will get executed when we try to run our program. When we want to run this program, what do? We say java space main. Okay, we compile this main.java, and that creates a main.class. Okay, when I say Java main, what I'm saying is Java main.class. Okay, if I remove main.class and I say Java main, it tells me I can't find a class named main. So when you try to run a program named X, it's looking for a file in your current directory named x.class. That's the executable in some sense. Okay. Now my main.java wants to use this class called even. When I start executing this, the JVM, the Java Virtual Machine, is going to try to figure out what an even is. It knows about certain things already. It knows about strings, it knows about doubles, it knows about linked lists, and so on. It does not know what evens are. So it's going to look in my current directory for a file called even.class. And if it finds it, it's going to assume that's the definition of this class even. Now if I don't have an even.class, if I have an even2.class, right? I can still compile I can try to compile my program, but it's going to warn me it doesn't know what this even is. Okay, I still have a main.class, and I can try to run this, but when I run it, I get an error at runtime saying I can't find this class called even. Now, if I do have an even.class, I can compile main.java. It doesn't find the source code for even, but it knows that the class file even.class is already in this directory, so it's happy with that. And then when I try to run this, it'll go ahead and it'll use with the even.class that it finds in here. So if I try to trick it, I've got an even.class now, which isn't really the class file for even. Right? It knows. It looks inside even.class and it says that's a bad class file. Okay? So the process of compiling actually takes in some of the stuff that we used to do with makefiles. Okay, some of this business of linking objects together to make an executable is sort of handled for us by the compiler and eventually by the JVM. Alright, so let's make a different main program. So I'm going to call this main2, because that's the file that I'm in. There's my usual public static void main. Let's just do an even x. I'll just stick with even numbers. Okay, so x is equal to 4, y is equal to 10, z is x plus y, and I'm just going to print out the value of that as an integer by calling z's toInt method. Or not. Awkward, I didn't write a toInt method. Alright, something else for me to fix after class. Okay, so 4 plus 10 is equal to 14, 1, 4. We can do things like this. X equals new even 4. I could say z is a new even number with value 4, and from that even number I want to run the add method with an argument which is a new even number of 10. and then I want to take that and I want to print it out. And that'll work just as well. I could also do this. I could make a new even number which is equal to 4. I could use its add method to add a new even number which is 10, and I could take the result of that and concatenate it to the string, which we'll call the toString method on that resulting even number, and return the string 1 space 4 and print that out. So this is a bit of what I mean when I say a lot of times if you do something that you think should work, there's a good chance it will, right? Now this is not necessarily something we would do a lot of, because this starts to get a little hard to read, right? Breaking it out into 3 variables and then assigning them values and so on is a little clearer, but we can totally do this, right? This is a completely fine thing to do from an object-oriented perspective and as far as the Java system is concerned. So does that make sense to people? All right, I'll take that as a yes or as a everybody has passed out from confusion. I'll take it as a yes. All right. So for PA1, as I said, you're only turning in one file, which is even.java. Okay, but to test it, you're going to want to write some main code that will let you, exercise your functions, make sure they're doing the right thing, and so on. And your code could look like this, right? This is straight from the assignment. Or you can write your own code, right? Or you can, play around with stuff like that. But you may want to write a test program that gets input from the user, okay, and lets you type in 2 numbers and then adds, subtracts, multiplies, divides, prints them out, and so on and so forth. It's up to you. But eventually we're going to need to do things where we get input from the user. So so let me show you how to get input. And it's a fair bit easier than using fgets and scanf and all that kind of stuff. We're going to use a built-in class, part of the standard Java distribution, called a scanner. And it comes from a package called java.utility.scanner. So we're going to need to import this in the beginning of our code. And so let's write some code. If you don't know how to do this, go to the Java documentation on that's linked to on Canvas. And when you get to the class scanner, first thing you see up here is Java util scanner. Okay, that's where this class actually exists. It's an extension of a Java language object. Okay, everything is actually, but the thing you want to import is Java utility scanner. And then there's descriptions of how to construct a scanner, and the methods that are available. We're just going to play with these for now. All right, so let's make our main class file. So we're in a file called scans. So public class scan. All right, so here's our main program. Okay, if we want to read from standard in, we have to create a scanner object. Okay, so how do we do that? We say I want an object of type scanner. I'm just going to call it input. You can call it whatever you want. It's just a variable name. It's an object. Equals new scanner. And we pass an argument system.in. This is like standard in C. Okay. So this creates a scanner for reading from standard in. So let's read one line at a time. So let's look at the methods available in a scanner. So there's a method called hasNextLine. HasNextLine returns true if there's another line of input on the scanner, and it may block while waiting for input. Okay. If there's not another line available, it will return false. So I'm going to make a while loop. I'm going to say while input.hasNextLine. I could say equals true, but you don't have to do that. Okay. HasNextLine returns an object of type Boolean. Okay, and a Boolean is exactly what we want in here. So I could say, is this Boolean value equal to true? But it's just as good, it's even better to just say while input.hasNextLine. And because this method is called hasNextLine, it kind of reads pretty naturally, right? This statement says, well, there's another line available from the input. Okay, well, if there's another line of input available, let's read it. So how do we read a line from the input? There's a method called nextLine. It's part of the scanner still. nextLine advances the scanner past the current line and returns the input that was skipped. Okay, so it basically reads a line of input and returns it as a string. Okay, we only want to call this if we know that we have a next line. Because if we don't have a next line and we try to get a next line, we can get an exception, an error, which says if no line was found, no such element exception. Okay, we'll try that in a minute. But we're just going to say string temp equals input.nextLine. And let's print out what that input looks like. So we'll print out the value of temp inside angle brackets, and we'll go back up to the top of our while loop. And when we come out of the while loop, I'll print a message saying we're done with input, and we'll just exit from our main method. Okay, so this is our test code for what used to be fgets. But we're using a scanner instead. So compile it up, and then execute it with scan. And it should just be sitting here waiting for some input. And it tells us temp equals some input, some more stuff. And then I'm going to hit Control D. So hold down Control D and press D, and it comes back right away and says done with input. Okay, so this is a basic input loop. We iterate while our input, which is a scanner, has another line available, and we say next line and do whatever we want to do with that line and just keep iterating on that until hasNextLine comes back false. And at that point, it tells us, does whatever we want to do outside of the loop. And you know, I could run this by redirecting input. So I could feed this, run this Java virtual machine to execute what's in the class file scan.class. but I'm redirecting standard in to come from scan.java. And if I do that, right, it does exactly what we'd expect. Each line that it reads is another line of this file. And you'll notice there's no annoying new line here. Okay, this is one of the things that you either love or hate about fgets. It always puts a new line at the end of lines. Not the case here. Okay, we're just getting each line of the file, and when we get to the end, we're done. So that's an easy way to read lines from standard in or from a file, one line at a time. But we can do other things. We can say has next. We can say has next, and it will just tell us if there's another token in the input. Well, what's a token? It's usually stuff that's separated by white space. Okay, and if there is a token, we can read it by saying next. So let me modify this code a little. You just look for has next and then read input.next and print that out. So now if I type in a line of input, this is a test, it went through my loop 4 times. Each time I did input.next, it read the next word from my input. Okay, and it's breaking things up on spaces, but you can change it to break up on other things as well. And so if we run this, but redirect from scan.java, right, we've got our source code one word at a time. And there's all kinds of things we can ask to parse from our input. For example, we could say has next byte, we could say has next int, has next double, has next float, and so on. So if you want to drive a program using scanners, we could do something like this. So let's read one number. So let's say, well, input has next int. So let's print out enter a number, and I'm going to print instead of print line so that it doesn't do a new line at the end. So I'm going to prompt the user to enter a number, and then I'm going to say, well, input has a next int. I'm going to say integer I equals input.next int. I'm going to print out a message that says you entered I, which is half of, and I'll print out 2 times I just to show that I'm actually treating this thing as an integer and I can multiply it by 2. And then I'll ask them to enter another number and go back up to the top of the loop. And then when they hit a Control D, we'll just exit the whole program. So we run our program. It says enter a number. I'll enter 45. It says you entered 45, which is half of 90. Enter a number, -12. You entered -12, which is half of 24. Enter another number. Let's try 2.5. Goodbye. Because I did not enter an integer. So has next int came back false. All right, so input and parsing is a little different in Java from what it was in C. Okay, scanner is really powerful. It's like, scanf, but a fair bit more controllable without knowing lots of little tricks. So if you expect an integer, just try next int, right? Or has next int. And if we don't do this, if we just say do this forever, right? So this is another thing. Java is trying to be smart here. It's telling me line 16 can never get executed, okay? Which is true because I'm in an infinite loop. So it'll actually refuse to compile if you have things that can't be reached in your code, which can save you from yourself, if you accidentally have a misplaced bracket or something. But it can also be kind of inconvenient if you're just trying to write quick code. All right, so let's go ahead and run this. Enter a number, 23, which is half of 46, -10, which is half of -20. Let me hit a Control D now, and I get an exception. Okay, so my exception is exception in main, java.util, no such element exception. Okay, if I go back to next int, I see it can throw an exception, no such element exception, which happens if the input is exhausted. Okay, I hit Control D, which means there's no more input available. So it threw an exception, no such element. It came from Java Utility Scanner, from a part of that called throw.for, which is at line 862 of scanner.java. If you looked up the source code, that's where you would see it, which comes from the next method, which comes from nextInt, which comes from nextInt, which eventually came from line 12 of scan.java. So line 12 is right here. That's where I called nextInt. So you get a fair amount of debugging information when something goes wrong. This is an advantage of running in a virtual machine. It's not that the CPU just got an exception because you tried to access a bad memory location. The JVM actually knows what the environment looks like, and when something goes wrong, it can give you this nice little stack trace of what exactly happened. Usually what you're interested in is the last message, right? These are internal. If you were writing scanner.java, you'd look at line 2076 to see where this was called from and so on. But usually we're just interested in the last line. That's what started the whole chain of events that led to this exception. Exception is just a fancy word for error. All right, any questions about that? All right, we will call it good for the day then. So check your email. If you got an email from me on PA0, send me a note back, and we'll take care of that. Otherwise, start looking at PA1 if you haven't already. I will update the assignment right away, and I will add a toInt method to my class. All right. Cool. Have a good rest of your day, and I will see you tomorrow. Or in office hours at 11, if you like.